Hi, I'm Haley, and my article is on the effects of physical exercise on skeletal muscles of rats with cerebral ischemia. So, the introduction. So what is it? So, the definition really is that cerebral ischemia occurs when there's an insufficient amount of blood flow to the brain. But really, to get more into it, so what really happens during the cerebral ischemia is that the oxygen and nutrients that are carried to the brain, through blood vessels, and those blood vessels are called arteries. So when an artery is blocked off, or if it bleeds, it lowers the oxygen supply to the brain, which can cause like brain damage or death of brain tissue. And if you look over here, lack of oxygen to the brain right here would cause a color. It's that gray color right there, and then you can see obviously this is all oxygenated, and then this is obviously blocked off, and then you can see like the buildup that goes into the blood vessel, and that's the artery getting blocked basically. So since this is a article about the physical activity on cerebral ischemia, I decided to add in why exercise is good for the brain overall. So basically, when you exercise your body's blood flow increases, which also means there's more oxygen, and that's flowing through as well. So the brain can be damaged really easily when there's not enough oxygen. So that can obviously cause muscle dysfunction or loss of neuromuscular movement. And that is honestly what we are actually testing in this article. We're going to find out and see if any neuromuscular movement or muscle dysfunction is affected by cerebral ischemia and or exercise. So the purpose of the article really is to understand and see if endurance training before induction of the cerebral ischemia has any effect on the recovery or use of motor functions post. So it's basically a treadmill test that they're doing, and the muscles that are being tested are the soleus, biceps brachii, and the tibialis anterior are the three we are going to be looking at. So the authors put the hypothesis as the rats that were part of the exercise training program process will influence the muscle recovery and reduce muscle atrophy of type 1 fibers after cerebral ischemia. And if you look around here, so you can see the normal muscle is bigger than the atrophied muscle, and that's what they're trying to avoid, any muscle atrophy. So we're going to see if exercise can help reduce that. So the participants, really, it's just kind of like the subjects here. They did 24 male Wistar rats, so all 30 days old, average weight of 140 grams, and obtained basically just from like a biological science center in Germany. That's where all the rats were from. Okay, so the procedure, kind of the methods, and so for the exercise process, half of the rats that were chosen at random were part of the exercise training program. Before the 5 weeks of physical training started, they did a 1-week adaptation. So they started really at 10 meters a minute for 10 minutes at a 0-degree slope, and increased by the end of the 5-day week to 12 meters a minute for 12 minutes at a 5-degree slope. So that was like their warm-up, and they're kind of like getting in shape before the actual physical training took place, which was 14 meters a minute, speed 5 days a week for 30 minutes, Monday through Friday, basically. And then the sedentary rats weren't just sitting around. I mean, they did go on the treadmill for 5 meters a minute, a day a week for 5 minutes. So they did do something, but nowhere near as intense as the rats that were in the training process. So this kind of is just showing after 5 weeks of training, the rats underwent the sham surgery or the ischemia, and they were all 72 days old. You can see right here, this is when they got the surgery. So a sham surgery is basically a placebo surgery. So it kind of just, does exactly what a placebo does. And a day and 2 days after the induction of the cerebral ischemia, the animals were classified on motor performance to see which ones were going to be used. So basically, I made this table over here. You can see the scores and the criteria of the inclusion criteria of the rats, and that was only the rats that were used only scored a 3 or a 4. So you can see what that meant. So they only used rats that were in spontaneous movement in all directions and were spontaneously moving in a circle towards the left. And then the rest were excluded. And then in this down here, you can just see kind of like just like a timeline of everything. You can see like the neural evaluation was a couple of days after, and that was this. And then the evaluation of motor performance started here. They did the day before, a couple of days after, right before the euthanization. So more of the methods and procedures. So the other things that they were testing for were the muscle fiber types. So kind of how dense all of the muscle fiber types were, like if they had a lot of type 1, type 2 in the muscles that they were testing. So in the biceps, soleus, and tibialis anterior in all of the rats. Cross-sectional area and body weight were also determined pre and post experiment. So, weighed in the beginning, weighed at the end to see if any atrophy was caused by anything. And to get the muscle fiber types, basically they use the dye and like the SDH prep. And then the two tests that they were really focusing on were the false step test for the front paws and the parallel bar test for the hind, so the back legs. For the false step, they basically had, they suspended the rats over a grid in subdivisions, and they observed for about 3 minutes, and every time they did the experiment, every fail to touch the grid correctly was recorded as an error, and then those errors were recorded for to see if there was any significant value between any of the 4 groups that we're looking at, the ischemic groups and the non-ischemic groups, and the ones that exercises versus not exercises. And then the second test they were looking at were the parallel bar test. So this is for the back legs, and this was all observed for 5 minutes. They were just shocked to move, but if both feet were on the same bar, an error was recorded for the same reason. So, and they were recorded at the beginning and the end of the experiment as well. So before the training, after the training. And yeah, so that was for that. And then now we're going to get into the results section. So this is actually for the false step test and the parallel bar test. So the false step, the highest number of errors we saw was in the sedentary ischemic group. So you can see this is all before surgery. These two right here, false step is on the left, parallel bar is on the right. Before surgery, these are all before surgery. So after surgery, you could see that the sedentary ischemic group had the most errors. So that was the highest for there. And then actually for the parallel bar test, you can see that the highest, the number of errors was in the ischemic exercise group, which is interesting. And the parallel, for the parallel bar test, the least amount of errors were actually, once again, in the control exercise group. Same with up here. Least amount of errors. So that was kind of like a trend of, that was like the most superior group with the least amount of errors and the most motor function, most movement out of all of the 4 groups. And this is kind of just like a bottom kind of explaining what these meant. And then down here, these are before euthanization. So before, after surgery, and then before euthanization are these two. So just a little bit more for the results. Muscle fiber type, cross-sectional area, and the body weight were the other 3 things that we were testing. So for the soleus, there was a significantly higher rate of type 1 fibers in rats that went through the exercise training, and higher number of type 1 fibers in the ischemic group compared to the control, which was interesting as well. And they were both significantly, significant. And then for the tibialis anterior, there were no significant values, so we kind of just can't assume anything for that. And then for the biceps, the exercise control group was the control exercise group again, had the most increase of type 1 fibers compared to the other groups. And then they also found a slight increase in type 2 fibers in the ischemic exercise group, and that might make sense because of how that they reacted in the false step and the parallel bar test from the previous slides. So now going into like the cross-sectional area, the larger fiber cross-sectional area was found in the exercise groups, which we kind of could have assumed more exercising, greater cross-sectional area for that. And then the sedentary group presented more atrophy like expected, and that was significant value as well. So we can kind of say here that the exercise group had a significantly less amount of atrophy rather than the sedentary group. So the exercising group obviously had a one-up on the ones that weren't exercising. And then the body weight in rats obviously all went down because each rat actually atrophied a bit, which was to be expected from either A, not really moving and being sedentary, and B, having cerebral ischemia induced. So the muscles aren't moving as much as they were. So now getting into the discussion, the group that was superior in performance, like I said, was the control group that exercised. They kind of had the least amount of errors throughout the tests and everything, more muscle fiber types, type 1. And then the ischemic exercise group had less errors than the sedentary ischemic group, which actually shows that exercise is neuroprotective, and it has that effect on these rats that could have effect in humans. That exercise training really did decrease those neurological like defects that could have happened, or less motor movement, and function. And then we also saw that the ischemic exercise group did not guarantee a better performance compared to the sedentary group, so we knocked that out basically. Cross-sectional area of the muscles that were observed were reduced, and this obviously decreased the, this was also going into decreasing like the body weight and causing atrophy and all of that stuff. And then surprisingly, the atrophy was greatest in the soleus muscle that they found, which was interesting. And then the exercise training pre-surgery led to an increase in fiber area and aided in preventing muscle atrophy in the animals of the exercise groups, especially the ischemic one. So overall, we really saw that the exercise did help prevent some type of atrophy compared to when they did not exercise in the sedentary groups. Now getting into limitations of the study. So I said they only used male rats, and then before the 30 days of life, they didn't really state where the rats were. I'm assuming they were in the lab, but they could have all had different physical activity levels. I know they all weighed the same, but in different areas possibly. And I said that they could probably have looked at capillary density to go into more detail, kind of more to see kind of from more like the type 1 fibers and stuff like that. And then just practical applications. So practical applications, I said, and future research. So for the applications, exercise showed to have significant values to motor function. So less fiber loss after the ischemia, and so therefore exercise possibly is preventing people from total muscle loss and motor function loss if they endure an ischemic episode in real life. And for the case of athletes, the training programs may have caused an increase in the proportion of type 1 fibers. And this is really after a long period of, moderate intensity endurance exercising and stuff like that. That's kind of like the best for this kind of stuff, is basically what they were saying. And then, so basically I'm just comparing that to athletes that all work at moderately. So they have, they possibly could have a less motor dysfunction after this kind of trauma. Future research, kind of getting into that. I said they could be testing the length of time for muscle hypertrophy to gain back. We didn't really see much in the time period that we had with the rats in this study. And then maybe just to test different muscles and look into other factors that might increase the ability to recover and for rehab purposes. So yeah, and that's the end of my presentation.